Hey guys, today we're going to work on section 5, basic differentiation rules. I think you're really going to like this section because instead of using the limit definition every time you want to find a derivative or a slope, you're going to use a rule. Now, these rules in the beginning may seem difficult and challenging, but the more you practice, the easier they get. So we're going to go ahead and get started with our basic differentiation rules. Now, I am not overly concerned that you necessarily know the names of them, but how to use them is important. The derivative of a constant function is 0. That is basically telling you the derivative of any number with no variable is 0. The reason is because the graph of a constant function is just a horizontal line. And the slope of that line is 0. So the derivative of -4, notice the notation, y prime is 0. S of t is 45, s prime of t is 0. F of x is 0, so f prime of x is 0. Y is kx over 2, so y prime is 0. K in that case would have to be any number. The single variable rule, the derivative of a variable with no exponent and no coefficient is 1. So what does the graph of y equals x look like? And what is the slope of that line? 1. So if f of x is x, f prime of x is 1. S of t is t, s prime of t is 1. X of t is t, x prime of t is 1. The power rule is one of the most important rules, and it is going to be used the most often. This is what it says mathematically. The derivative of a variable raised to a power is bring down the exponent times the variable to the exponent minus 1 power. So n is your exponent. X is the variable in the problem. So here is how that works. The exponent is 2. You'll hear me say for this particular rule, bring down, that means the exponent, and then minus 1, also the exponent. So bring down minus 1. So if y is x squared, y prime, bring down minus 1 is 2x to the 2 minus 1. 2x to the first power is just 2x. For part B, f prime of x, bring down minus 1 is 4x to the third. Now you think about if you were doing the limit definition of the derivative for each of these and how long that would take. It's definitely worth it to practice the derivative rules to make things faster. Sometimes you have to rewrite the function square root of x, x to the 1/2 power, before you bring down minus 1. Do not leave negative exponents in your answer. So y prime, bring down minus 1. 1/2 minus 1 is negative 1/2. Rule of negative exponents, move it opposite, change the sign. Y prime, is 1 over 2x to the 1/2 power, which is 1 over 2 square root of x. No negative exponents. Part D, rewrite x to the negative 1 power. Bring down minus 1. G prime of x is negative x to the negative 2, which is negative 1 over x squared. If you would like to try the next two, you may pause your video now. Rewrite x to the negative 2. Bring down minus 1. F prime of x is negative 2x to the negative 3, which is negative 2 over x to the third. And for part F, rewrite x to the negative 2/3 power. Bring down minus 1. 2/3 minus 1, 2/3 minus 3/3 is negative 5/3. So y prime is negative 2 over 3x to the 5/3 power. All right, so we're going to look at the general power rule next. All this says is if you already have a number in front, when you bring down your exponent, just multiply. So you're still going to bring down and minus 1. So y prime would be 6x. Part B, bring down and minus 1. Rewrite for C, 6x to the 1/2. Y prime, bring down, minus 1, negative exponent. I know I'm going through these kind of fast. Pause your video at any time. Let me know where your questions are. Rewrite G prime of x. Don't forget that notation. Bring down, minus 1, negative 6 over x to the third. Rewrite f prime, bring down, minus 1, negative 2 over x to the 3/2. Rewrite negative 8x to the negative 4/3. Y prime, bring down, minus 1, negative exponents. 32 over 3x to the 7/3 power. If you know and understand the examples we've done so far, all you have to do for part 5, example 3, is you're doing each derivative of each individual term. So you would do the derivative of x cubed, the derivative of negative 5x squared, the derivative of 2x, and the derivative of negative 7. So your sum and difference rules just basically says you have to do the derivative of each piece. So bring down minus 1, 3x squared minus 10x plus 2. The derivative of negative 7 is 0. Part B, y prime, bring down, minus 1, bring down, minus 1, bring down, minus 1. And then the derivative of negative 1 is 0. Sometimes, like in part C and D, you will have to rewrite before you bring down minus 1 for your power rule. So this is x to the 1/3 plus 5x to the 1/2. And then find g prime. Bring down, minus 1, plus, bring down, minus 1, and then evaluate those negative exponents. 1 over 3x to the 2/3 plus 5 over 2x to the 1/2. And you can use your rational exponents or you can use your roots. Typically, square roots are used for x to the 1/2 and really not much beyond that, but that's your choice. everything is good except this last one, and that's going to be 4x to the negative 1. First two terms are already written okay for us to find the derivative. Bring down minus 1. Minus 3 goes into 6, 2 times 5. Bring down minus 1. Bring down minus 1. And then evaluate your negative exponent. So 15 halves x to the 1/2 minus 10x to the 2/3 minus 4 over x squared. All right, same thing for E and F here. We're going to rewrite, I'm just going to rewrite the whole thing. 3x squared minus 4x to the negative 2 plus 2x to the 1/2. H prime, bring down minus 1, bring down minus 1, bring down minus 1, and evaluate those exponents. So 6x, and let's see here. Bring down. Questions, make sure you mark them. Now, if you have a rational function, divide that x out first. So rewrite your function as 8x squared plus 4x minus 3x to the negative 1, and then find your derivative. 16x plus 4 plus 3x to the negative 2 is 3 over x squared. All right, derivatives of sine, cosine, and tangent functions. Now, for sine and cosine, we're going to use what I call the derivative circle. So think of the unit circle. And on the unit circle, you have coordinates x and y, which are cosine and sine. So this would be cosine in a positive direction, cosine in a negative direction from 0. Sine is y, sine in a positive direction, and sine in a negative direction. It is a derivative circle. And here's how the derivative circle works. You are welcome to draw this on your papers anytime you are working with derivatives of sine and cosine, not tangent, but sine and cosine. So you always start here. I always start here. You can start wherever you would like, but you have to go in the correct direction, clockwise. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is cosine. And the derivative of negative cosine is positive sine. So the derivative of sine is cosine, and the derivative of cosine is negative sine. Formulas you need to make sure that you remember. And one that's not part of our trig circle, and another one you will need to remember, is the derivative of tangent, which is secant squared x. Now we're going to look at these graphs and kind of do a little analysis here. You should recognize that this is our sine function. It starts at 0, 0, it goes up to 1, then down, and then up. So up, down, up. That's our sine function. So what's happening is you are increasing Then you are at slope equals 0. Then you are decreasing. Then you are at slope equals 0. And then you're going to increase. And then you have the cosine function. You know that because you're starting at 0, 1, and you go down, down, up, up. So we're going to draw just some little boundary lines here. All right, from 0 to pi over 2, your graph is above the x-axis, which means your slope is going to be greater than 0. It is equal to 0 here. Here you are below the x-axis, so your derivative is less than 0. And then here you are above the x-axis, and your derivative is greater than 0. And again, here, y prime is equal to 0. And if you analyze this first graph, increase above, slope is 0, y-intercept, decrease below, y-intercept, increase above. So you have your function and its derivative, which is why the derivative of sine is cosine. If you want to graph derivatives, you are going to use that Math 8 notation. And there are going to be times where you're going to want to check to see that the graph that you have created is correct. All right, let's look at example 5. Using the limit definition for the derivative, and that's up here at the top for you, we can derive f prime for each of the following trig functions. You will verify the derivative of the sine and cosine functions by using the sum and difference formulas from pre-cal. I know you guys did not learn those, so what I'm going to do is give them to you. You probably will not need them beyond this activity. So recall the limit as h approaches 0 of sine h over h was 1, and the limit as h approaches 0 of cosine h minus 1 over h, or 1 minus cosine of h over h, is 0. All right, sum and difference formulas. For cosine of x plus h, your value is cosine of x, cosine of h, minus sine of x, sine of h. And for sine of x plus h, it's sine of x, cosine of h, plus cosine of x, sine of h. And you're going to need that for a substitution here as we work on parts A and B. All right, show that the derivative of sine is equal to cosine. So show that the derivative of sine is equal to cosine. So f prime of sine equals the limit as h approaches 0, sine of x plus h minus sine of x over h. Remember, we're using our limit definition of our derivative. We know that the sine of x plus h has the value that you see here, so substitute that in. Limit as h approaches 0 of sine of x cosine of h plus cosine of x sine of h minus sine of x all over h. So there's your sine of x plus h minus sine of x over h. Now, I'm going to use these values here because I see that they have a greatest common factor of sine, and I know the one in the middle does too, but I want to see if I can convert it into this one or this one. So the limit as h approaches 0, take that sine of x out, times cosine of h minus 1, plus your remaining term, cosine of x, sine of h over h. Now, if you took a sine out of all three terms, you're not going to be able to convert it to one of these trig limits. So we want to make sure that we make it to where we can. So we're going to split that up. The limit as h approaches 0. Remember, we're proving that the derivative of sine is cosine. So sine of x times cosine of h minus 1 over h plus the limit as h approaches 0 of cosine of x sine of h over h. And I want you to look at that last line we wrote for just a minute and think about how we can take these two trig limits and use them here to do our last step. The limit as h approaches 0 of cosine h minus 1 over h is 0. The limit as h approaches 0 of cosine of h minus 1 over h is 0. And 0 times sine is 0. The limit as h approaches 0 of cosine x times sine of h over h. The limit as h approaches 0 of sine of h over h is 1. And 1 times cosine x is cosine x. So there's your proof. If you would like to try to do that for part B on your own, feel free to pause the video. I'm going to go through this one just a little bit quicker than we did the last one. So f prime of cosine of x equals the limit as h approaches 0, cosine of x plus h minus cosine of x over h. Substitute your value from the top, cosine of x plus h. Don't forget your limit notation out front. Cosine x, cosine h, minus sine x, sine h over h. You're going to do the same thing you did last time. So what I have here, I forgot my minus cosine of x. Throw that in there, sorry about that. So we're looking at this first term with cosine and this last term with cosine, and we're going to take that cosine out. And we're going to split them up. And then we're going to use those trig identities at the top. So again, this will equal 0, and this will equal 1. And we have negative sine of x as our answer. So the derivative of sine, or f prime of sine, is cosine of x. And the derivative of cosine, or f prime of cosine, is negative sine of x. And we have proof that in A and B. Finally, part 7, example number 6, we're going to look at derivatives of the natural log and exponential functions. Here are the derivatives that you need to know. If f of x is e to the x power, then f prime is also e to the x power. It is its own derivative. If f of x is natural log of x, then f prime is 1 over x, and x must be greater than 0. So we're going to apply those rules now. You're also going to see some log properties here, so if that's something that you need some review on, let me know. You're going to do a rewrite when you have an exponent, and that exponent comes down in front of your function. That's one of the log properties. The number in front becomes the exponent, or the exponent becomes the number in front. In this case, the exponent becomes the number in front. So 3 times 1 over x is 3 over x. When you multiply, you add the exponent, so rewrite of x squared plus ln of e to the x. Bring down those exponents, and remember, we're not finding our derivative yet. We're still in our rewrite. So 2 ln x plus x ln e. And if you will recall, ln of e is equal to 1. Now we're ready for our derivative. 2 ln x, 2 over x. The derivative of the x is 1. Rewrite for c, ln x minus x to the negative 1. So you have a natural log function and a power rule here for your derivative. H prime of x equals 1 over x plus x to the negative 2, which is 1 over x plus 1 over x squared. Division implies subtraction. Ln 2e to the x minus ln 3x. So we're going to break this down as a 2 times e to the x. So addition, ln 2 plus ln e to the x. And then this one is also going to be a multiplication, so minus parentheses ln 3 plus ln x. We still have a little bit of a rewrite to do here, bring down the exponent, and then we'll be ready for our derivative. Ln 2 plus x ln e minus, distribute that negative, and remember that ln of e is 1. Say y prime. Ln of 2 is a number, and the derivative of a number is 0. Plus x ln e. Ln e is 1. The derivative of x is 1. Minus ln of 3. Derivative is 0. Minus ln x. Minus 1 over x. Y prime. 1 minus 1 over x. For a lot of you, reviewing these properties is going to be harder than finding the derivatives. Rewrite. This is ln 4x cubed plus ln e to the x. Bring those exponents down, remembering that 4 times x cubed is what you see here. So that's ln of 4 plus ln of x cubed plus ln of e to the x. That's ln of 4 plus 3 ln x plus x ln e. Remember, ln of e is 1. Now you're ready for your derivative. The derivative of ln of 4 is 0 plus 3 times 1 over x plus the derivative of x is 3 over x plus 1. Rewrite in part F for your second piece. Pi e to the x minus x to the negative 2/3. Just because your derivative looks kind of funny and it has pi and e to the x and a cubed root in it, you don't do things any differently. So now we're ready for our derivative, g prime of x. Remember, pi is a number. So the derivative of pi e to the x is pi e to the x. Bring down, minus 1, and evaluate that negative exponent. All right, guys, this is the end of section 5. As always, let me know if you guys have any questions, and I'll talk to you soon.